So in the last class, we were discussing about your clear input and pre input as well as active to pre. Okay, and I told you what, that clear and pre is used with your NOR latch, whereas clear and pre bar means clear bar and pre, that is used with NAND. Clear or clear bar, it is used for what? It is used for taking the flip flop to reset state, and I told you what, that it is used in your up counter. Why? Because in up counting, our sequence goes from 000 to 111. So I need to initialize with my initial state. So in up counter, the initial state is 000. So that is why I need to reset the state of your counters. Okay. Now we have what? Am I audible properly? Screen sharing, is it okay? Screen sharing is okay, but am I audible? Okay, fine. No, because you can see there is some connection issue over here. It was breaking for a bit for me, yes. So there is some connection issue at my end only. Okay, even you guys, Raju and me also, I am also having very bad connection over here. So it's okay. So now it's again good. Okay, so what I told, pre and pre bar, it is used for what? It is used for taking the flip flop to set state, and it is used in your down counter. Why? Because in your down counting, the counting is from 111 till 000. So basically I need to take my flip flop to the initial state, and initial condition in your down counting is what? It is your 111, or all the flip flop has 1. That means what? You need to basically set or preset the state of your flip flop. Okay. So now let us see the first example. Okay, can you identify and tell me what will be the mod of this counter? Very quickly. First tell me whether this is up counter or down counter. See, directly you can say that this will be what? This will be up counter, even without checking the signs and all. See, there are two ways. So first way is what? You check over here. So this is active, sorry, this is negative edge triggered. So that is why negative. And this is taken from your non-complemented, means the clock for the next consecutive state. It is taken from your what? It is taken from your non-complemented output. So plus different sign means what? Up counter. So this is one way. Or you can see what? You have clear bar. So I have told you, whenever we use clear or clear bar, basically that means what? It is up counter. So you can see over here, clear bar, up counting. So this is basically up counter. Okay, fine. So if this is up counter, I want you to tell me what will be the mod of this counter. Okay, so counting will happen like this. So this will be your MSB, this will be MSB, and this will be your LSB. So QC, QB, QA. So this clear bar, it will be activated when this Y is equal to 0. Okay, whenever this Y is equal to 0, this clear bar will be activated, and immediately this A flip flop, B flip flop, and C flip flop, it will reset itself. Okay, the moment this Y is equal to 0. So let us check then, as we have already seen that this is what? This is your up counter. So the counting sequence will be like this. Means I cannot draw it properly. So let me make space over here. So y you can see it is what? So that is QC QB. So QC dot QB whole complement, as this is your NAND gate. Okay, fine. So now let us see for this QC QB, as one of the input is 0. So this will be what? This will be 1. Over here also this will be 1. This will be 1. At this moment you can see for the first time this will become what? This will become 0. Okay. This will become 0. I have taken QB QC. Oh, sorry. So this is QB QC, na? So this will be also 1, and this will be also 1 1. For the first time you can see you will be getting 0. So all this state, this one, this one, this one, this one, this one, and this one is going to be counted by this up counter. But what about the state? Is it a valid count or is it an invalid count for this particular counter? See what happens the moment this becomes 0. Okay, and when it is becoming, when QC is equal to 1, QB equal to 1, QA equal to 0, for the first time y is becoming 0, and the moment this y becomes 0, as there is no propagation delay over here anywhere, so immediately this will become 0. And the moment the clear bar input gets activated, as this is active low clear, so input is 0. So the moment it gets input, what it will do? Immediately it will do what? It will reset all the flip-flop. So immediately after this state, you will go over here. You won't be coming over here. So this is your invalid state. Invalid state. Okay. So this will not be counted. So this counter basically having this structure, so it will count from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5, again from 5 to 0. So this is your mod 6 up counter. Tell me if this is clear or not. Mod 6 up counter. Is this clear? Any doubt? Okay, fine. So now over here, what I have taken a finite propagation delay in this NAND gate. Okay, so this NAND gate has what? It has your finite propagation delay. So now let us try to see basically what happens over here. Okay, so the same case I had taken when del t was 0 in the last case, you can see. Now I am taking that del t is not equal to 0. That means there is some finite propagation delay. So very quickly, okay, so I have drawn it over here. So that is okay, fine. It's okay. So very quickly, let us draw over here. Okay, so you can see these are all the negative edges. Okay, so you can see what? That initially your QA, we have your QA over here. So QA is going to do what? It is going to toggle continuously. Okay, QA is going to toggle. So we will even draw for Y also. okay, simultaneously. So QA is going to toggle like from 0 to 1, 0 to 1 like this. Don't draw the diagram. Nobody is going to draw now because I will be erasing few part. So nobody is going to draw. First, I will be drawing the normal up counter. Okay. And then I will be manipulating the diagram. So that is why I am warning you, don't draw, or else you will have to then again redraw this diagram. So these are the negative edges of QA. Okay, so this is your QA, and the negative edges of QA will serve as your trigger for QB. So at all the negative edges, QB will be toggling. Okay, so QB will toggle. Okay, so now let us mark the negative edges of QB. So these are the negative edges of QB. Now this negative edges of QB will act as your trigger for QC. Okay, fine. So this is your QC. Now look what happens to Y. So I have drawn basically what? I have drawn the counter without this. Okay. Without this, I have drawn my counter. Okay. I have drawn my counter without this. Now look what happens basically. So when I use this, you can see the input of this NAND gate is what? It is QC QB. So Y is equal to what? QC dot QB whole complement. So anywhere your flip-flops, they don't have any propagation delay. Propagation delay is only in this case, okay? In this NAND. So now look, this state is what? It is 0, 0, 0. So what is Y over here? So I am drawing Y also. So Y is equal to QC dot QB whole complement, and the moment this goes to 0, what will happen? Basically this clear will be activated because this is active loop. So initially this is at 1. Now look over here. So this is what? This is 0, 0, 1. So over here also QC QB complement. So this will be high only 1. Now look over here. So this is 0, 0, sorry, 1, 0. So again QC QB. So this is again 1. Over here this is 0, 1, 1. So over here also this is 1. Now look over here. This is 1. This is 0. This is 0. So again this will be 1. At this moment also it is what? It is 1, 0, 1. So over here also this is what? This is 1. Now look over here. In this particular case, after this clock pulse, so this is your 0th clock pulse. So I should write it over here. 0th clock pulse, first clock pulse, second clock pulse, third clock pulse, fourth clock pulse, fifth clock pulse. At the end of fifth clock pulse, look over here what is happening. For the first time you can see over here you are getting 1, 1, 0, and when this becomes 1, you can see what? That this NAND gate, its output will become 0 for the first time. But there is what? There is propagation, finite propagation delay. So what will happen if there is a finite propagation delay del t? So after, if suppose this becomes 1 1 at t equal to 0, so after del t seconds, this output will become 0. So here also what happens, that for del t amount of time, this is going to be still high. So these are all 1. Okay, so it will stay at 1, and after that it will go to 0. Okay, it will go to 0. Now look, basically when this goes to 0, so this del t is very small, very small. This del t is in microsecond or millisecond. Here you might think that this is very big value compared to the clock, but this is very small value. Okay, just for making you understand, I have drawn the width of this del t a little bit more compared to your TCLK. Okay, so this is 1 clock period, so I have drawn it comparable with this TCLK, but it is actually very negligible. So I will write over here also, del t is very less compared to TCLK, but here it is looking like this. So what will happen, the moment this goes to 0, so immediately if this goes to 0, clear input is being what? It is given high. So immediately all the flip flop will go to 0. So this will go to 0. So now from here, your counting states are going to differ. So I have drawn the wrong way. Why? Because this was when this clear input was not present. So I need to redraw it once again. So after 101, immediately my states are going to be what? See now, it will be 0. Okay, so there will be no transition over here. This will keep on continuing like this. Okay, but this, it will be resetted to 000. So in the next clock pulse, this will become 0, and it will wait for the next edge of this QA, and at that edge it will go again toggle. Okay, and you can see this is what, this is positive edge. So over here we will get the negative edge. Okay, so this will be the negative edge. Okay, okay, so this will be the negative edge. So this also has become 0, and this will once again toggle over here. Okay, and what about this one? So immediately this is momentarily 0. Okay, this is momentarily 0. Now what happens, you can see over here, as your state is resetted to 000. So now what happens, the input, it changes from 1111 to 00, and the moment this becomes 00, this y will become 1, but it will become 1 after del t seconds after your application of input. So what will happen, again after del t seconds, this will go to 1, and this will stay over here. So in total, this width is del t, and this complete from here to here, it is what? It is 2 del t. Okay, this is 2 del t. So remember this, that basically the total amount of delay phased over here is what? It is 2 del t, and you can see the count sequence is again becoming 000, 001, then 010, 011, then again this will be 100. So I cannot draw over here, and this will keep on continuing. Okay, so tell me if this is clear or not. Is this clear? Look over here, is this clear or not? Tell me. See, basically this duration, now look very carefully. Okay, so let me zoom this a little bit. Look, This is known as your this duration. This duration. It is what? This is del t. Now this is known as what? This is known as your glitch. Now what is this glitch basically? Glitch is basically the time for which we have your unused state. We have unused state. So I will explain. First you understand that this is glitch. Now when this was 1 basically, so over here what happened? Let me zoom out. So note this del t time. Okay, this del t time is basically this much time. From here to here till the time this was 1. Okay, this was 1. So during this time basically what will happen, that ideally your counter will count what, because this was what, if you can see this was 1 and this was also over here going to be 1. So this was 6 110, if you remember, because at precisely at 110 we changed our state. So you can see for del t time in the counter there was the state 110, but as del t is very small compared to this clock, so this 110 state, it will be momentary, and that is why this is known as glitch, because this state was not at all required. Tell me, did you understand glitch? What is glitch? What do we mean by glitch? Did we understand what is glitch? Okay, so the last concept you can see over here. So glitch is what? Glitch is basically an unwanted state. Okay, unwanted state that is achieved due to what? That is achieved due to your propagation delays. Okay, so now you have understood glitch. See, glitch is only for del t time. Okay, glitch is happening for del t time, but you can look over here that this y, it changes its state of, means over here at this clock pulse, basically at this clock pulse precisely our flip flop, it changed its state from 101 to 000. So basically after we, means after the clear input was activated, this y took total 2 del t time basically to reset our counters. Okay, so y is happening for 2 del t, but glitch, it is happening for only del t time. So this is also one more very important concept that we need to note over here. Oh no, so now this is very small. So very quickly note this down and then I will zoom it for you guys once again. So whatever you have understood, I am giving you 2 minutes to note this. So if you guys have any doubt, you can ask. So I had told in the last class only, today's session, it will be very conceptual. So I will zoom this area once again. First you quickly make this diagram and then note this. So remember that this state 6, 110, this is momentary. It happens, it occurs only for del t, whatever is the propagation delay. Okay, and this 110 state is known as glitch. Okay, so very quickly, and let me know if you have finished this or not. So once or twice these questions were asked. Okay, what is the duration of glitch, for how much, means after how much time is your counter getting resetted, all those things you will see there are a lot of questions. So tell me very clearly, have you understood this or not, all of you? Shruti, Raju, Piyush, Bhumika. today I won't be loading you much, okay, because there are very conceptual problems over here. So I will be keeping the class very less so that you don't load up, okay, because lot of questions are asked. So very quickly you try to understand, write it down, and we will move on to the next concept, okay. So today's session is basically very much conceptual, so that is why I will leave you early also. Okay, fine. So noted, everyone. So I will zoom this part once again so you can note it. Later on, I will send the slides also. And when I send the slide, you can zoom in also how much you want. Okay, quality won't be affected. So this is actually the beauty of online teaching. Okay, so you can zoom how much you want and the quality it won't be getting affected. Even at your end also. So quickly note it down. So duration of y is how much? It is 2 del t, but the duration of glitch is only del t. So after 2 del t, your states are changing from 1012 000. But glitch is happening only for del t time. Okay. So now, okay. I think I might have messed up over here. Now this is okay. Okay. So now basically we have done what? We have done mod 6 using active high clear. Okay. We want to do using active high clear. Active high clear means what? We want to use clear. See, in the last example, we used clear bar. But now I am telling I want to construct a mod 6 counter using clear. So that means what? So write all the states. I will even tell you the shortcut trick for this one. See, basically you want what? If it is given you want a mod 6 counter using active high clear, that means you are using up counter. So in up counter mod 6 means this will be valid. So mod 6 means what? You have counting states from 0 to 5. So this will be valid state, this will be valid, 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 valid. These two states will not be valid. So over here, your clear input, is it activated? So no, it is not activated. Over here also it shouldn't be activated. Over here also no, no, no. Over here also this should be no, and over here this should be yes. Okay, this should be yes. Now if this is the case and over here I am using active high clear, so that means active high clear gets activated when it gets input as 1. So all the places this should be 0 0 0 0 0. For the first time over here this should be 1. What about this case? What should I put over here for y? 0 or 1? What should I put? No. Why should I put 1? Already your counter, when it encounters this 110, immediately it goes back to this state. So this state will never come. Even in glitch or momentarily, this state will never come. So why we will not reach ever? So this will be don't care. Remember, this will be don't care. So now if I want to write what will be the expression for y, so you can do what? Just make a k-map. So y should be basically a function of QC, QB and QA. So that you can get by making a K-map. Please understand all the concepts very carefully, because if you don't understand, then you will complain that sir, we couldn't understand this. So 90% of the students, they usually don't understand this parts only. Okay. So this is QC, QB, QA. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So 0, 1, 2, 3, 4, 5, 7, 6. So you can see from 0 to 5, these are all 0. Okay, so for 6 it is 1, and for 7 it is don't care. So I can make a group of 2 like this. So this will be what? This will be QC, and over here what do we have? QB. So you can see y expression for y is actually QC dot QB. Okay. So tell me, is this clear or not? So this is how basically we derive. Okay. This is how we basically derive. Now you might even want, see, this is basically the expression of QC, it means y in min term. Okay. This is min term. Now you might say, sir, we don't want min term, we want max term. So even that you can do. How? So you can make one group of 4 like this, and what you can do? One more group of 4 you can make like this. Okay, so this will be what? Over here you can see, if you want to write y in terms of max term, so in this you can see QB is equal to 0, so that is QB plus over here QC. Okay, so QB plus QC, yes. So this is okay. So you can see QB plus QC. At this, just wait a minute. Have I done something wrong? So over here we are getting QC. I should have got complement. So 0, 0. Over here I am getting 1. So this will be activated over here only. Have I made some mistake or what? This is okay. This will be 1. Okay, so this will be QC plus QB. Okay, so I require QC plus QB to be 1. Somewhere I am making some mistake. Okay, so if I use this, okay, see, max term is what? Y is equal to QC dot QB. Yes. So y is equal to QC complement plus QB complement. Max term is equal to POS. Yes. So no, when we actually group in max term POS, I have told you, POS when we group, basically what happens that your complemented term is written as normal. Okay, so complemented corresponds to 0 and non-complemented corresponds to 1. Okay, so you can see in this group of 4, basically we have what? QB is equal to 0 common. So that is why I have written like this. So this is 1 max term, and in this we have QC equal to 0 common. So this we have over here. Okay. Are you trying to understand what I am saying? Piyush, did you understand? Somewhere I feel I am doing some mistake. So basically when we use OR gate, I should be getting just wait a minute. I had used active high clear. Okay. Yeah, so this is correct. QC, QB. This is okay. Now, if I want to change it to active means OR, so then I am thinking what to do. Okay. So this is correct. This is correct. But look, whenever we use, so I will tell you, whenever we use actually clear, okay, we search for one. We search for one. Why? Because clear will be getting activated when we give input 1, and clear bar, it will be getting activated when we give 0. And as over here we are basically writing the min terms, you can see I have written it in min term form. Okay, everything is written in min term form. So that is why this clear is constructed using and this clear bar is constructed using NAND. See, last time I was getting qc.qb whole complement. qc.qb whole complement. This time as I am using active high clear, I am getting what? I am getting AND. So I cannot construct this using OR. Okay, so this is wrong. I cannot do this. Okay, I cannot do this. I cannot construct it using OR. So now you should always remember this, that clear, it is constructed using normal AND gate, and clear bar, it comes with NAND. Okay. So now there are trick for clear and clear bar. See what is that trick? So clear and clear bar, it is used with what? It is used with up counters. Okay, up counters. So your counting sequence can be 0, 0, 0. See, now every time you cannot make this truth table and then you are doing what? You are writing the expression for this. So directly also you should be able to write. So now this will be what? If your counter has only this two state, so then this will be what? This will be mod 2. If it is counting this 3 state, then it will be mod 3. Similarly, this will be mod 4, mod 5, mod 6, mod 7, and mod 8. Now see very carefully. So when you are writing for clear bar, and if it is your mod 2 counter, okay, so tell me one thing, when is clear activated? Clear is activated when we get 0. Okay, when we get 0, at that time clear will be getting activated. And when do we get 0? When basically we have one complement. Okay, when we have one complement, at that time we will get 0. So search for ones over here, because in your up counter, so listen this very carefully, in up counter basically you have to reset the 1 to 0. Okay, basically you want to go to your, I told you what, like from 0, 0, 0 we go till 1, 1, 1. So if suppose it is what, it is your mod 3 counter, so the valid count should be 0, 0, 0, 0, 0, 1, 0, 1, 0. So only this 3 state should be there in the counting sequence. The moment we have 0, 1, 1, if for a mod 3 counter, this counting should not come immediately. Your counter should go over here. Okay, so these three are valid state. This is what? This is your invalid count. So what basically I need to do? I need to reset this two ones. So in clear and clear bar, always search for one. And in clear bar, basically you have to use NAND gate. So over here, you can see this is one. So you need to reset this one. So you should write QA complement. If it is mod 3, you are going to write, means you need to reset this to 1. So you will be writing what? QB complement. Over here, you can see for mod 4, there are two ones. Okay, there are two ones. So you are going to write what? QB dot QA whole complement. Search for the ones always. See over here, if you want to write for mod 5, it will be QC complement. Okay. Now for mod 6, if you want to write, you can see C and A, both of them are 1. So you will be writing QC dot QA complement. Mod 7, this will be QC dot QB complement, and this is mod 8. So over here you are going to write QC QB QA complement. Okay. So tell me if this is clear or not. Is this clear? Is this clear, everyone? Now look, for clear, basically clear is getting activated when it is 1. So 1, how can you get? Simply using AND. So look over here. Over here QA is 1. So you are going to write QA. Over here QB is 1. So QB. Over here both QB QA. Here QC. QC dot QA. Here it is what? QC QB. And this is QC QB QA. Okay. So very quickly note this down. Sorry, what I have written. You guys didn't even tell me. So this is mod 1, mod 2, 3, 4, 5, 6, 7. So you guys didn't even tell me. So that is why I was thinking what has happened over here, means mod 6 I am getting like something else. So in mod 1, basically what you have? In mod 1 there is only one use state. So you can see 0 will be the only use state. In mod 2, you have two use states. So 0, 1, again back to 0. So this is mod 2. In mod 2, this will not be valid state. Whenever your counter, first it will count this state, then this state. The moment it comes to this state, what will happen? Your clear or clear bar will get activated, and again you will go back to 0, 0, 0. So very quickly write it. Did we understand this concept? Any doubts? See, in GATE exam, now how they ask you question. So I will give you one question. So they will ask you mod 14 up counter using clear bar, and they will give you expression, or they will give you logic gates like this. And over here, let us assume A is MSB. Okay. So they will give you like this. A, B, C means D like this, or they will give you It's okay. So this is option A, option B, option C, option D. So such kind of question you will see in GATE exam. So now tell me what will be basically the configuration of Y. So tell me. Option D. Okay, very good. What about others? A. Anyone else? D. Okay, so we have 2D and 1A. So look, mod 14 up counter. So that means for mod 14, we basically require minimum 4 flip-flops. Okay, 4 flip-flop is required because for using 3 flip-flop, we can have from 0 to 7, that is 8 state. But here basically we have mod 14. That means our count is from 0 to 13. So that means what, we require 4 flip-flops over here. And out of that 4 flip-flop, A is MSB. So now we require counts from 0, 0, 0, 0 to 1, 0, 1, 1. Okay, so this is what, from 0 to 13. So this is mod 14 counter, up counter. The moment this counter hits 110, that is 14, this state, it should not be used immediately. When momentarily your counter comes to this state, it should go back over here. So this is your invalid state. So over here you can see this is 110. It is given A is MSB, this is B, this is C, this is D. So that means you need to reset this 3 flip-flop. So you can write it as A dot B dot C whole complement, and that is given in your option D. So this is what, this is your NAND gate. Tell me if this is clear or not. Is this clear? Now similarly, tell me for mod 11, what will be the expression? Again, A is your MSB. So A is your MSB. So now even we don't require all this, just simply represent 11 in your binary. So 11 will be what? This is 11. Okay, so if this is A, this is B, this is C, this is D, so this will be A, C, D whole complement. Finished. So now you can see all this concept, it will be very easy. So mod 11, you can directly write it like this. Tell me if this is clear or not. Is this clear? So if you wanted to write mod 11 using your what? Using your clear input. If you wanted to write mod 11 using clear, so that will be ACD. Or if you wanted to write mod 14 using clear, so that will be ABC. So it depends whether you are using clear or clear bar. If you are using clear bar, then you require NAND gate. If you are using clear, you require AND gate. Tell me if this concept is clear or not. Is this clear, everyone? Is this concept clear? Yes or no? Okay, so now let us, okay, so I have taken one example. So this already we have solved. Okay, so now let us try to design what? Mod 6 down counter using pre-bar. Okay, so mod 6 down counter using pre-bar. So look over here, we have pre-bar and we require mod 6 counter, down counter. Means we know what? Whenever we use pre or pre-bar, we are down counting. So now see very carefully. very, very carefully. Later on, you can draw the diagram. See, even the concept of glitch and all those things, it will remain the same over here also. So once again, I am not repeating those things. Okay. Okay, fine. See. So now if I want to get over here mod 6 down counter, so basically my count sequence will be like, so this is 7, 6, 5, 4, 3, 2. Oh, so I should have drawn it properly. कोई बात नहीं, I will write it once again. Now see. So basically we want what? We want mod 6 down counter. What am I doing here? I'm so sorry, okay? So continuously we are writing like this. Na? So mod 7, this is down counter. So it will start from 1, 1, 1. So we require what? Mod 6 down counter. So this is 7, 6, 5, 4, 3, 2, 1, 0. So basically this will be valid, 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 valid. The moment our counter hits this state, it should go back over here. Okay, 1, 1, 1. And this is pre-bar. So for pre-bar getting activated, basically this should be 0. Okay, this should become 0. So over here pre-bar is 1, because if this becomes 0, pre will be activated. So that is why pre-bar should become 0 at this state only. So over here this will be 1, 1, 1, 1, 1. Over here this is 0 and this will be don't care. So now let us find the expression of y or pre-bar. Acha, tell me one thing. Whenever we are in down counter, okay, so down counter, basically what are we searching for? Means, see over here, our initial state is 1, 1, 1. The moment we reach this state, basically all the zeros should be set to 1. Okay, it should be set to 1. So remember this, that basically in down counter, the flip-flop should change from 0 to 1 once your pre or pre-bar is activated. Okay, so whenever you activate either pre or pre-bar, your flip-flop should change its state from 0 to 1 immediately. So keep this thing in mind. So this is A, B, C. So look over here from 0, sorry. So one thing, make a note of this, what? Of your minterm number. This is 7. So don't start writing, see, this is 1, 2, 3, 4, 5, 6. and you filled 1, 2, 3, 4, 5 and 6. Okay, and you are happy. Okay, we are getting. No, wrong. So over here you can see this is the min term corresponding to 7th cell. So from 7 to 2 it is 1. So 7, 6, 5, 4, 3, 2. Everything is 1. Then first time we are getting 0 over here, and this is don't care. Okay. So either you can do what? Either you can group ones or you can group 0. So I will group 0 over here. Okay. So if you group 0, so you can see what you will be getting. So this is A plus B. Okay, A plus B, you are getting it as what? You are getting it as your Y. So the expression of Y is what? It is A plus B. A plus B. And this is correct also. Why? Because for the first time you can see A plus B will become 0 at this state. So if you want to make this normal counter as a mod 6 counter, so you need to do what? So little bit difficult to draw. So I should have actually written the pre over here, but it's okay. No, this diagram is not correct. So let me represent the pre at the bottom. Usually preset is written over here with the normal, okay? See, whenever I was writing, just a minute, give me. See, whenever I was writing clear, anywhere you can see. So clear I always write with your complemented output, and preset is always written with your normal output. Pre bar, it is always written with your normal output. So usually that is the way we write, but over here as we don't have space to represent, so that is why I have taken it downwards. Okay, but this is incorrect. So this we got A plus B. Now this will be given to all your preset inputs. So now remember one thing. So pre, whenever we use pre bar, we use OR gate. We use OR gate. And whenever we will be using pre, we will use what? We will use NOR gate. Why? Because for pre to get activated, what we require, so listen very carefully now. For pre to be getting activated, we require the input, means basically this should become 1, then only it will get activated. So look over here, all the places this is 1, and at this place this is 0. So if I want to reverse this, basically what, if I use pre in all these places, this should be 0, 0, 0, 0, 0, and at this precise moment it should be 1. And how can I get this? Basically, if I use NOR gate, then I will be getting what? I will be getting 1 over here, and I will be getting 0 in all the remaining places. Tell me if this concept is understood by all of you or not. Yes or no? Is this clear? So I will write it once again. So with clear, so first is up counter. So this is not complete yet, and this is down counter. So with up counter, we use two things. With down counter also, we use two things. So one is what? Clear complement. One is pre complement. So with clear, we use AND gate. With clear bar, we use NAND gate. With pre, we use what? We use OR gate. With pre bar, we use what? We use NOR gate. Okay, we use NOR gate. Okay, so now tell me, is this clear? Very quickly tell me, is this clear? See, everything we have written already. Okay, everything we have written. See, over here we have used clear. So with clear bar we have used what? We have used NAND. With normal clear we have used AND. Okay, and over here you can see with pre bar we are, sorry, so I have mistakenly written over here. So with pre bar we are using OR, and with pre we are using NOR. So I will even, means I will, yes sir, pre is equal to NOR, yes. So I will tell you the trick also over here. See, in up counter, listen very carefully. In up counter, basically the count sequence is 0 0 0. So I am everywhere taking 3 bit, okay, to 1 1 1. So basically in up counter, if I want to construct like mod 1, mod 2, or anything mod 3 4 5, so basically I need to reset this 1, any of the ones, to 0. So basically in the counter, what I am doing, I am searching for ones so that I can reset it to 0, so that once again I can go to this 0 0 0. So in up counter, basically you are searching for 1. You are searching for 1. So when you use clear, so at that time you will be using AND. Why? Because in AND, the product of two variables like QC, QB, immediately it will give you 1. In clear, we search for 1. For clear to be getting activated, we require what? For clear to be activated, we require 1. And already we are searching for ones, so that is why it is AND gate. But in clear bar, it is getting activated by 0. It is getting activated by 0. But we are searching for ones in up counter. So if we are searching for ones and your clear bar is getting activated with 0, so that means we require NAND over here. Now similarly come to down counter. In down counter, basically we have like counting sequence like 1 1 1 till 0 0 0. So if suppose we have mod 1, mod 2, or any mod, so basically what we require, basically any of the zeros, like if you have mod 3. So in mod 3, basically what you will be having. So 3. So just wait a minute. So this will be 1 0 0. Okay. So in mod 3, basically your state will be what? It will be 1 1 1, 1 1 0. Then you will have 1 0 1 and 1 0 0. So all these three states will be counted in mod 3. The moment you hit this state, you need to return back over here. So in mod 3 or in down counter, basically you are searching for zeros so that these zeros can be converted to 1. So in down counter, you are basically searching for zeros. You are searching for zeros. And you can see over here, pre will be getting activated by 1. But we are searching for zeros over here. So I need to convert this 0 to 1. So how can I do that? I can use it with the help of NOR. And in pre-bar, it is getting activated with what? It is getting activated with 0. And in down counter, we search for 0. So it's okay. Just simply add it. We will be getting your OR. So tell me, have you understood this concept? So no need for memorizing anything. So whatever I told you, if you think you will find it in some textbook, you won't ever find it in any textbook. So this actually I have got using my own observations. Okay, over the years I have observed this. Now even I will tell you trick for down counter also. For down counter also I am going to tell you tricks. Okay, but at the moment you tell me, did you understand that with clear why we use AND, with clear bar why we use NAND, with pre why we use NOR, and with pre bar why we use OR? Everyone tell me, Shruti, Raju, Piyush, Bhumika. Everybody understood? So this is very conceptual, okay? So after this topic only I will stop, okay? Or else you guys will be like, it's okay. Means the next topic is more conceptual, okay? So this one, decoding. So if I take decoding today, there are like concepts of propagation delay and all those things you will mess up, okay? So it's okay. In the next session only I will take. So today you just understand this much. Okay. So now let me tell you the trick for down counter. So see over here. So down counting. See, if you haven't understood anything, please ask me. Okay, please ask me. But don't later on, if you don't understand, it will be very, very difficult. Okay. So now look over here. If your counting sequence is counting only, means counter is counting only this two state, then it will be what? It will be your mod 1 counter. Okay, mod 1 counter. Sorry, if it is counting just this state, okay, so it will be mod 1. If it is counting this two state, then it will be what? It will be mod 2 counter. So you can see this state will be invalid in your mod 2 counter. Only this two state will be over here. In mod 3, basically this three states will be counted and this will be invalid. You can see there are three states, so that is why this is mod 3. Similarly, you can go till mod 7. So in mod 7, this will be invalid state. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, so this will be what? Mod 7 counter. Okay. So now, how do we write basically this pre-bar and pre? I told you what? Whenever we are writing pre or pre-bar, basically that means what? We are using down counter. And in down counter, we actually search for what? We search for zeros, because I have to reset this 0 to 1. See, our initial state is all 1, 1, 1. So I need to convert zeros to 1. So if it is your mod 1 counter, I told you what? Basically, pre-bar will be using what? It will be getting activated with 0. Okay. So over here, we will be simply using OR gate. So this will be QA. Over here, this will be QB. Over here, this will be QB plus QA. Over here, this will be QC. Over here, this will be QC plus QA. Over here, it will be QC plus QB. And over here, this will be QC plus QB plus QA. Now, similarly, if you want pre, so pre gets activated with 1. But here, actually, we are searching for zeros. So 0 will be converted to 1 with the help of your NOR gate. So simply whatever you have written over here, so you need to do what? You need to complement everything. So you will be getting NOR gate. So tell me if this concept is clear to you guys or not. Now I will be asking you few questions and that will decide if you have understood this topic or not. First tell me, have you understood this? Clear? Okay, fine. So now very quickly write me mod 19 down counter. Mod 19 down counter. How are you going to write it? Using pre and pre-bar, both. And over here, A is MSB. A is MSB. So mod 19 down counter. So let me see how quickly can you write this. See, writing mod 19 up counter is very simple. Mod 19 up counter. Why? 19 you can write it as 16 plus 3. So this is 60 means 19, and if this is A, this is B, this is C, this is D, this is E. So using clear, we basically need what? We require AND gate. So this will be A, D, E, and clear bar, it will be A, D, E complement. But with down counter, it is not so simple. So everybody noted the question? Done. Okay. So what answer are we getting for mod 19 down counter? See, first of all, for representing 19, you require 5 bits. Okay, 5 bit you require. So now will you start writing from here? 1, 1, 1, 1, 1. Then what? 1, 1, 1, 1, 0. Like this. Will you write from 31 to 0 and then check where we get mod 19? For pre-bar B plus C, for pre, acha, different answers we have. Okay, fine. So now how do we actually write this? Mod 19 down counter. See, there is one trick. Okay, there is one trick. So everything, whatever I am telling you, so this is all my own observation. Okay, means from teaching also, from studying myself. So these are all my observation. So look over here. If suppose over here, see here it is very simple. This is 3 bit. So if I tell you write mod 6, you can instantly do what? You can start from 110. You know for mod 6 from 111 to 001. This will be the count, and at at your, that's what I am writing for mod 6 I am telling. Okay, so mod 6, okay, let me write over here only. So for mod 6, your valid count will be from 111 to, you can see, 010. Okay, so this is 7 and this is 2. So from 7 to 2, you have 5 U state. 7, 6, 5, 4, 3, 2. So you can see what? There are 6 U states. 7, 6, 5, 4, 3, 2. Okay. Now, if you don't know this, so what can you do? Very simple. Look over here. So everything you guys, I guess Shruti might be correct, but other than that, everybody is wrong. So look over here. So for mod 6 down counter, so first write 6. 6 is what? It is your 110. Now take complement of this bit by bit. So this will be what? This will be 001. So basically this 001 in your mod 6 down counter will be the invalid state. So the moment you get this state, your counter will get what? It will go to state. So in this state, search for all the zeros. So you can see if this is A, this is B, this is C. So A and B are 0. If I want to construct this mod 6 down counter using pre, so that will be what? That will be A plus B whole complement, and over here, sorry, means I have taken over here C as your, means I have taken CBA over here. So let me take it over here also, CBA only. So if that is the case, so this will be CBA. So you can see this will be what? This will be C plus B whole complement. And look over here, mod 6 directly I have found out using this only. Okay, so now if you go back, and I have told you what? Mod 19 down counter. So look very carefully what I do. First represent 19 in binary. So that will be what? 10011. Okay. Now do what? Take complement bit by bit. So that will be what? That will be 01100. And in your, means this is what? This is A, B, C, D, E. Okay, so I am sorry, I guess few of you might have written it correctly. So now look over here. Basically, this is what? Now this counting, when I start from here 1 1 1 1 1, when I come to this state 0 1 1 0 0, this will be the invalid state. At this state I will be going back. So over here, if this is A, so if I start writing it using pre, so pre requires what? Pre will require 1 to get activated, but this is down counter, we search for 0, so this will be A plus D plus E whole complement if I write using pre, and for pre bar this will be A plus D plus E. So very good, those of you who have written. So pre-bar, Raju has written, very good Raju. Okay, with pre-bar it is A plus D plus E, and with your pre it is bar. Okay, fine, very good Raju. So did we understand this concept? Tell me yes or no. Did we understand this concept? Everyone? Those of you who couldn't get answer? Very good. Okay, so now we have over here, okay, so this is your homework. You are going to write this yourself. So I have taken mod 19 down counter with pre, mod 14 up counter. So here I have assumed QA to be your LSB. Okay, so A is your LSB. A is your LSB. So with this you have to do what? This will be your homework. In the next class we are going to solve this. Now let us study about synchronous, clear and preset. This is very simple. Okay, there is nothing over here. Synchronous, clear and preset, basically what happens that it is synchronized with the clock. The clear and preset input okay, it is synchronized with the clock. Now if suppose I have a mod 6 up counter, okay, mod 6 up counter. So listen, this will be the last topic, then I will do this comparison between synchronous and asynchronous counter, then I will leave you. Okay, so decoding of counter, that is very conceptual. So in the next class we are going to do that. Okay, so look over here, what is this synchronous, preset and clear? So I told you what, that synchronous, clear and preset, it is basically what, it is synchronous with your clock. Okay, synchronous with your clock. So if that is the case, if I have to construct mod 6 counter, so look over here, basically it will be what? Mod 6 counter means honestly tell me, have you guys understood whatever I have explained from the last 1 hour? See, be honest, it's okay. It's even if you don't understand something, you can ask me. Okay, so you can ask me, it's okay. But be honest that you have understood or not. So this will be your homework. Okay, okay, chalo. First solve this one and rest will be homework. Okay, so solve this mod 23 down counter using pre. So very quickly I need answers from all of you. Okay, so this is what, this is your 23, 16 plus 4 plus 3. Okay, so this is 16, 4, 3. So this is 23. So here I have told you A is LSB. So this will be B, C, D and E. So now take complement. So this will be 0, 1, 0, 0, 0. Okay. So what you have written AC means I told A is LSB. It's what you guys have taken. It's what you have done. 23. This one I have told you. Mod 23 down counter. 23 is what? 23 is 16 plus, means 16 plus 4 plus 3. So this is 16, 4, 3. Okay, so we are searching for what? In down counters, we are searching for zeros. Okay, and here we have pre. So with pre, we use what? We use your NOR. So this will be E plus C plus B plus A. Complement. So who have written this? Raju has written A, C, D, E. How? A, C, D, E. ECBA. So Piyush has written correctly. Raju, how means? First you gave me the correct answer. Now you are giving me wrong answers. Shruti has also written using pre-bar. So that is ACDE. ACDE. So what is that, Shruti? Piyush has written correctly only. What about others? How many of you got this correct? I have taken A as MSB, so clearly it is written. It's okay. If you have taken A as MSB, so this will be then A, B, C, D, E. So those of you who have taken A as MSB, they might be getting answer as A plus C plus D plus E whole complement. Still I am happy. Okay. Still I am happy if you got this correct like this. Okay. Now see, synchronous clear preset. Okay, synchronous clear preset. So let us assume that this is QA. So we already know how your mod 6 up counter looks. So these are all the negative edges that we have. So first I am constructing a an up counter, okay, 3-bit up counter. Then I will explain what is synchronous and what is asynchronous clear preset, okay. So now the negative edges of this will serve as the trigger for your next flip-flop. So you can see this is the negative edge. This is the negative edge that we have. Okay, negative edges. Okay, fine. So now this is what? This is your QB. And the negative edges of this one will serve as your trigger for the next flip-flop. Okay. So this is what? This is QC. So let me write the state. So this is 0, 1, 0, 1, 0, 1, 0, 1, 0. This is 0, 0, 1, 1, 0, 0, 1, 1, 0. This is 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So we have the states. Okay. So now look over here. If suppose it is mod 6 up counter. First time we are using what? We are using your normal, whatever clear and preset we have studied up till now. It was asynchronous clear and preset. Okay. Asynchronous clear and preset. Whatever we have studied till now. That means what? In asynchronous clear and preset, it is not synchronized with the clock. It is not synchronized with the clock. That means what? If by chance mod 6 up counter we have. So that means this will be counted, this will be counted, this will be counted, this state, and this state will be counted. Now, in your mod 6 up counter using asynchronous clear, basically if I activate my clear over here, any place, it doesn't matter. The moment I activate my clear at that very precise moment, suppose if I activate my clear, for mod 6 I will be activating, if suppose in the last, means when I had drawn this diagram, see here it was del t time, okay, it was del t time. So now what I am telling, if suppose I, due to some reasons, okay, due to some reason, if suppose I activate my clear over here, okay, for asynchronous clear, what will happen? Immediately these all states will be taken, this, it will be taken, but after this your counters are going to be resetted. But with your, means asynchronous clear, another way of understanding, asynchronous clear can be activated at any place in the clock. I can activate it over here, any place, and it will basically take the state of the counter to 0 immediately at any point. If suppose I am activating the clock, means activating the clear over here, okay, so immediately it can take your counter B and C to 0 at the very instant, okay, it will not wait for the next clock to reset the state. But with asynchronous clear, with synchronous clear, that is not the case. If suppose I activate the clear over here, okay, if suppose I activate, this is my clear input has been activated, remember, at this point I have activated my clear. Now immediately your counter cannot, means this cannot go to 0, because you can see this is up counter, and in up counter I have told you we search for ones and we take it to 0. So over here this is 1, this is 1, so immediately this should have gone to 0 0, okay, 0 0 0, but that is not the case. Your synchronous clear, as you can see, it is synchronized with the clock, so it will wait for the next negative edge, and at the next negative edge, means over here, after this will go to 0, this will also go to 0, and this will also go to 0, okay, so 0 0 0, this will go over here, okay, and again you can see this will become 1 over here, so like this count will go on. So basically in synchronous clear, if suppose it is given mod 6, you have to construct mod 6 up counter, okay, using synchronous clear. So in asynchronous, when we had mod 6, so at that time the counting sequence was what? It was from 0 0 0 to 1 0 1. If I had constructed it using asynchronous clear, now if I construct it using synchronous clear mod 6, so now my counting sequence will be from 0 0 0 to your 1 1 0, means this state, previously this state was considered as invalid in your asynchronous clear. Now this will be also considered as a counting state. So whatever count we have in your normal asynchronous clear and preset, in that we need to just add 1 for your synchronous clear or preset. Tell me if this is clear or not. So if suppose if I have mod 9 down counter, okay, mod 9 down counter, and I am using it, okay, I am using mod 9 down counter using synchronous preset, okay, synchronous pre. So what will be the count sequence? in mod 9. So basically 9 is what? 9, it can be represented using 4 bits. So that is 1001. So if I take complement of this, so this will be what? 0110. So previously your count states would have been like from 1111 till 0110, and immediately when your counter reach this state, it will go back over here. Okay, in your, if this was using asynchronous pre. But if this is using your synchronous preset for mod 9, this state will be your valid state. Valid state. So previously over here, your counting sequence for asynchronous pre, it will be from 111 to your 0111, because this is 6. One more means one above of 6 is what? It is 0111. Okay, so this will be 7. So 7 will be over here. So this many states will be counted from 15 to 7. So this is mod 9. But in synchronous pre, even the 6 will be counted as your valid state. So tell me, whatever I have told you, have you able to grasp it or not? Is this clear? Is this clear, everyone? Tell me. So in asynchronous clear or pre, we will count the state where it is invalid also. Okay, we will count that state where it is invalid. It will be a valid state. Previously, the state where in asynchronous clear preset it was invalid, that state will be counted as valid state in your clear, means in your synchronous clear and pre. Tell me if that is clear or not. Understood, everyone? Tell me yes or no. Did we understand? Okay.